Alright, let's simplify this. When people hear computer science, they often imagine complicated code, hard maths, and screens full of symbols. But computer science is not really about memorizing weird syntax. It's about how to think clearly, break problems down, and give instructions so precise that the machine can follow them exactly. That's the real idea. And once you see it that way, computer science starts to feel a lot less scary. So, what is computer science really? It is not just typing code. It is learning how to solve problems with logic. It is about planning, testing, fixing, and improving. It is about systems, instructions, and clear thinking. In simple words, computer science is the art of telling the machine what to do in the correct order with zero ambiguity. That's why it is less about memorizing and more about problem solving. Here is one of the biggest ideas of the whole video. Humans understand intention. Computers follow exact words. A person can usually guess what you mean. A computer usually cannot. If your instructions are vague, incomplete, or out of order, the result can go very wrong. A human might say, "Oh, I know what you meant." A computer says, "I did exactly what you said." And that's why precision matters so much. This is a powerful way to think about it. Computers are not magic. They are not mind readers. They are not creative guessers. They are obedient. They follow instruction exactly. So if your result is amazing, that usually means that the instructions were amazing. If your result is broken, confusing, or wrong, the instructions probably need work. Now let's separate two ideas. First, the machine. The computer, tablet, phone, that's the hardware. It has power, it can act fast, but power alone is not enough. Second, instructions. Instructions give direction. They tell the machine what to do. When you combine powerful machine with clear instructions, you get a predictable result. The connection between machine and instructions is where computer science lives. Now here comes the word that sounds scary, but it actually isn't. Algorithm. An algorithm is simply a step-by-step set of instructions used to solve a problem or complete a task. That's it. And the funny part is, you already use algorithms every single day. Brushing your teeth, that's an algorithm. Tying your shoes, that's an algorithm. Making a sandwich, that's an algorithm too. So in a real sense, you have already been thinking like a computer scientist long ago before writing any code. So what makes an instruction good? A good instruction is clear, specific, in order, and testable. That combination is everything. Because good instructions lead to good result, but weak instruction create confusion, mistakes, and failure. In other words, good instructions equal good results. This is another key message. Code is just instructions with structure. Programming may look technical, but the core idea is simple. You give the computer an input, some rules, and it gives you back an output. If the order is wrong, the result is wrong. If a step is missing, the process breaks. If the sequence is clear, success becomes possible. So, code is not magic language. It is just a structured way of giving instructions. And here is something important. You don't even need a screen to understand coding. You can teach coding ideas without a computer at all. Imagine a robot on a path trying to reach a goal. Your job is to guide it using simple commands like move forward, turn left, turn right, reach the goal. That is coding logic, because the real point is not the device. The real point is the sequence of instructions. Let's imagine the instructions are: step 1, move forward. Step 2, turn left. Step 3, turn right. Step 4, reach the goal. That works. Why? Because the steps are in order. They are specific, clear, and they lead to the desired result. That's a working algorithm. But now imagine this instruction. Step 1, move 2 steps. And suddenly, boom, the robot hits the wall. That is a buggy algorithm. The machine did exactly what it was told, but the instruction was wrong for the situation. And this is a huge lesson in computer science. A bug does not always mean the computer failed. Sometimes it means that the instructions were not correct. So what do we do when the instruction is wrong? We debug. Debugging means find the bug, fix the step, try again. That is all debugging really is. It is not some mysterious expert skill. It is careful problem solving. You look at the instructions, you find the mistake, you improve the sequence, and then you test again. That process of fixing and refining is a normal part of computer science. So, what should we remember from all this? Three big ideas. Algorithms are step by step thinking. Precision matters. Bugs can be fixed. That is the foundation, not just for coding, but for computational thinking in general. Let's finish with one of the most important ideas in the entire lesson. The better the instructions, the better the output. Precision is not boring. Precision is power. Think about a simple task like brushing your teeth. To a human, brushing your teeth feels obvious, but to a machine, that's not enough. You would need to say, pick up the toothbrush, turn on the water, wet the toothbrush, turn off the water, add the toothpaste, brush your teeth. That level of details is what computers need, because a computer does not understand intention. It understands instructions. And that is the real difference between human intention and computer interpretation. A contrast shown clearly in this video. So in the end, computer science is not just about coding. It is about logic. It is about precision. It is about turning ideas into clear, structured instructions. And once you understand that, you start to see computer science everywhere, in your routines, in your recipes, in problem solving. And in that way, we break big tasks into small steps. That is the real foundation. And honestly, that is what makes computer science so powerful.